Dave is just stealing my line now. All right. So I'm the second French guy, even though you don't sound French at all. So what's your secret? So is he French? They're taking over. CorkDev. Okay, so tonight Pierre just told us about a lot of tools and how they interact together. I'm just going to talk to you about Git for tonight. So why am I giving this talk? So as Dave just said, literally you're just stealing my line, right? Git is a powerful tool, but it's difficult to master. I mean, when I started using it, I started using it probably maybe a year and a half ago. And it took me a while to really know what was going on, okay? So don't expect, this talk is too short for an actual tutorial, okay? Don't expect to come out of this talk and, yeah, I know everything about Git, I'm a Git expert. So what I intend to do next half hour or something is for those who have never used Git or have heard of it but never actually used it, give you a few pointers to avoid, prevent you from, making the same mistakes I did when I started using Git. And for those of you who are used to using Git, hopefully I'll give you a few tips that maybe you don't know about. Okay. So the need for version control. Nobody writes perfect code. Mistakes happen. Servers go down. Fires happen and stuff like that. So you need some kind of safety net. And also, that's just one aspect. Okay, you need a way. If multiple collaborators working on the same project, they need a way of integrate the work that they've been doing on their own. Okay, you need a way of merging work coming from different collaborators. So, I mean, I'm not teaching you anything here, but it's just for the benefit of making sure that everybody's on the same page. So, in very plain terms, not teams, a version control system, VCS, is, you could think of it as a camera combined with a photo album, and you take snapshot with that camera and you fit them nicely in your photo album. And then if needed, if you screw things up, you can revisit the past, okay, go back in history and revert to a state of your project that you were happy with, that was more stable, okay? That's the basic idea. So where does Git fit in this picture? So go back to the mid 2000, the Linux kernel, the team who was developing the Linux kernel was using a VCS version control system called Bitkeeper. And it was a bit of a controversial choice because it's a proprietary software. The thing is, it had a free community edition, so it was free for the Linux people to use, okay? But suddenly, in 2005, they said, you know what, you are losing too much money here. Or Bitkeeper said, it's not free anymore, you have to pay, guys. So the Linux project, they decided we can't, it would go against everything we believe in. So they said, we need a different version control system. So Linus Torvalds starts looking around, what could we use? And in typical Linus fashion, wasn't too impressed. And he looks at Subversion, he says, well, it's actually on YouTube. It says, Subversion has been the most pointless project ever started. So obviously he wasn't too happy with what he saw. And he rolled up his sleeves and decided to build his own version control system, and Git was born. So what is Git? It's a distributed version control system. I'm going to explain what distributed means. It's free, it's open source, cross-platform. It has good performance overall, and has some features to prevent data corruption. So if your files get corrupted, you'll know pretty quickly. And it's primarily geared toward text files. So if you need to keep track of binary files, you can do it, but well, depending on your project, you may want to use something else. So Git is primarily for text files. And fast forward to today, Git is the most popular version control system, at least according to that Stack Overflow survey. Follow the link. I think SVN is the second, but distant second. And actually, a lot of people I talk to who may not necessarily be software developers, when I mention Git, they say, "Oh, do you mean GitHub?" GitHub is actually more, has more recognition on the street than Git itself. But those hosting platforms, GitHub, Bitbucket, they're powered by Git. Okay. So I mentioned Git is a distributed, as opposed to centralized version control system. What that means, it means different things. Okay. So what that means is that you don't have a special central repository. Okay. With SVN, you've got your repository on the server, and you don't have a repository on your own machine. Okay. With Git, all the collaborators have their own repository on their own machine. And in theory, at least, none of those repositories is more canonical than another. Okay, your repository, in theory, is as important as mine. Of course, in practice, people agree, oh, we're going to have this repository on this server that's going to be the repository, okay, that holds the truth, okay, and you can play around in your own repository if you want, but this is the true, this is the repository that reflects our project. And what that means is if you remove that central repository, that means that you've eliminated pretty much the single point of failure that was your central repository. Back in the day, when you had only centralized version control, if you didn't have a mirror of your central repository and the building burned down, your project was gone pretty much. Whereas if loads of people have their own repository, even if my laptop crashes right now, I can always get back most, maybe not all of my work, but most of the work that was done in that project. I can recover it from, I don't know, Dave, if I work with him, okay? Sorry. Another thing is you don't have any locking mechanism, so that means developers can work on the same, that's gonna come back. No locking mechanism means Dave and I, for example, can work on the same file at the same time, and that's not a problem, okay? With some centralized version control systems, if somebody is amending a file, that's it. That person is working on that file and nobody else can work on that file until the lock is removed. That's not the case with Git. Also, a very important point is that commits are local. So what that means is not only can you write code, but you can save, you can take snapshots of your progress, even if you're not connected to any server, okay? I can get on the plane and keep working on my project, keep developing, and I can save the progress that I'm making as I go. I don't need to, push to the server in order to take snapshots of my progress. Merges as well are local, so I'll explain what that means. And what that means as well is that, so back in the day, there was the fear of, you were kind of holding off. You didn't want to commit too quickly because you might break the build. So you wanted to be really careful. Is this next commit? If I commit right now, am I going to break the build? Am I going to push something that's bad to the central repository? So you were kind of holding off, and you wouldn't commit as often. With Git, you can commit as often as you like, and you're encouraged to do so. Okay, you can save your work more often, more frequently, and that allows you to do more incremental steps and experiment more. And also with distributed version control systems such as Git, branches are cheap. So branches are the main mechanism used to integrate work from different people, and you can use them to experiment. You can create them throw them away when you don't need them, and you're encouraged to use them liberally in your workflow. Problems with Git. So as I said, the learning curve is quite steep. If you look at the man pages, you get a lot of technical jargon that can be, can set you back a bit. Even worse, some of the terms that are used are kind of counterintuitive, okay, and I'll discuss that in a moment. Another objection that you could have is that the API is flat. So if you take another a competitor of Git, Mercurial, their API is a bit more compartmentalized, and means that, you know, if you want to use a relatively dangerous command, you have to unlock something. Whereas with Git, all the commands are available, and you may, you know, if you don't know what you're doing, you may cause some damage. So what I want to do in the next few slides is, as I mentioned, some of the terms are kind of unintuitive. I'd like to go over some of those terms in order to fix ideas and hopefully to give you a better learning experience of Git than I had when I started with it. Actually, just before can I just get a show of hands, like who uses Git? Who has heard of Git? Okay, pretty much everyone in the room. Who uses Git every day? Okay, that's about half. Okay, that's great. Okay. So, working tree. The working tree, as soon as you run this command, you've created a Git repository in your project folder, okay? And what Git calls the working tree is just the contents of that directory, minus what Git uses to, for bookkeeping. So when you actually run that command, it creates a .git folder in your project folder. The working tree doesn't include that. So the working tree, you can think of it as what's in your project folder right now. And then what's a commit? A commit is, it's also known as a revision, or more informally, a snapshot, and it reflects the state of your project as it was recorded by you or by somebody else at some point in the past. That's what a commit is. And I'm only mentioning this in passing because there won't be any, I won't show you many Git commands, but to make a commit, you would use that command git commit. One thing to, here are a couple of things that you need to know about commits. So first of all, they're revisions, not delta. So Git doesn't store the differences between one stage and the next, okay? In some, like in SVN, it would store the difference between so if I'm making a commit right now, it will only store what's different between right now and what I did in the previous commit, okay? That's not entirely true because for saving memory, some compression is actually used. Each commit is uniquely identified by a SHA-1 hash. Okay, you can think of it as a unique identifier, and yeah, that's about it. And each commit is immutable. So once you've created a commit, you cannot change it. Even for those of you who are used to Git, if you run, you write a commit and you write your commit message, and you make a stupid typo in your commit message, and you go, oh, okay, I need to fix that, obviously. So you run git commit -- amend. When you do that, you're actually not changing the original commit. You're just creating a new one that resembles the old one. Okay, so every commit is immutable. All right, and the last thing you need to know is how commit relates to one another. So commits in your repository form what's called a directed acyclic graph. So what that means is just a graph with no cycles in it. examples of that, if you're a Java developer, the inheritance graph of Java interfaces would be a DAG as well. So commits, you see that those arrows are important. So a commit only points to its parents, okay? If I make a commit right now, it's only going to point at the previous commit. It's not going to point at, it's not going to refer to commits that came after it, okay? Okay, and the staging area, so they also use the term index, but I'm not a big fan of that term. I prefer the term staging area because it just lends itself to a better metaphor, in my opinion. So you can think of that as an intermediate layer between your working tree and the next commit you're going to do. I said committing is like taking a snapshot. So if you think of it as committing as taking a snapshot, staging is about composing the shot. So you can imagine you're about to take a class picture or something. I'm about to take a class picture. I notice that Anthony over there is, making bunny ears to the guy sitting next to him. If I notice that, I'm gonna change things. I'm composing the shot. I'm making sure everything is okay. So in practice, that would mean, putting all the files that are relevant to the next commit in the shot, okay, and nothing that's irrelevant. Everything that's irrelevant, I wouldn't put in the commit. Staging is about preparing the next commit, okay, and you do that with the git add command, okay. Branch. Now that's a big one. That's arguably the most misleading term of all Git jargon. If you go to Stack Overflow, half of the questions about Git are about branches, and people get very confused about what a branch is and what a branch actually refers to. And it's probably a holdover from older version control system. So what a branch is not is a sequence of commits. So if I go back, don't think of that as a branch, okay? This is just, some commits, a string of commits, but it's not a branch. A branch really means it's really a reference to a commit. So it's just something that points to a commit, okay? And the commit in question is called the branch tip. And a branch just marks a point of the project that we left off, okay? We'll return at this point of the project at some stage. We still have some development, maybe. It just marks a point of interest that we'll return to at some stage. The current branch, so you can have multiple branches in your repository. When you start, you only have one that's called master by default. But if you have multiple branches and you don't know which one you are, you can run git branch, and it's going to mark the current branch with an asterisk. And also, when you make new commits, so I'll show that on the next few slides, but every time you make a commit, the current branch moves along with them, okay? Moves along and points to the latest commit. So a useful metaphor, of course, no metaphor is perfect, but a useful metaphor, for me at least, is if you think of your repository as a book or as a photo album that chronicles the progress in that project, then a branch is one of those bookmarks, okay? It's a point of interest, you're going to return to it. You can move it, you can, as you write or read the book, you can move the point of interest, but it's something like that. It's a good way of thinking of branch. So as I said, branches are cheap. You're meant to, in Git at least, you're meant to use them, create them, merge them, etc. Throw them away when you don't need them. Okay. And final thing about branches, you shouldn't think of commits as belonging to one or another branch. Commits don't belong to any particular branch in general. Instead, you should think of commits as being reachable or unreachable from a particular branch. So here I've got A, B, C, D, E, F. Those are commits. and the labels there in yellow are branches. And so if I were to list the commits that are reachable from my master branch, for example, I would have A, B, C, F. But that doesn't mean that they belong to master in particular, because exactly the same commits are reachable from bug fix. So if you get confused, don't go to Stack Overflow and go, I need to, don't speak of commits as belonging to any particular branch. In general, that's just an ambiguous way of saying things. Now, if I go back to my previous slide, I've got a head label there, and you see that it's pointing at a branch. Okay, it's pointing at my master branch, and what that head label is pretty much a "you are here" sign on your repository. Okay, it tells you where you are in the history of your project. You can always go back to the past. I'll show you that in a minute. But head tells you this is where you are right now. Okay. And typically, it points at a branch. Okay, it doesn't point at a commit directly. When it does point at a commit directly, you're set to be in detached head state. Now that's a good one to know, because when you go back, so let's say I've started my project and I've made 5 commits, and here what I've done is I've run a command to go back to my 3rd commit to maybe inspect how things were. Maybe I don't know, maybe you reuse some of that. And in this case, you see that head is pointing at a commit directly instead of pointing at a branch that points at a commit. And in that case, you'll see this term, this phrase in the Git messages that you get at the command line. So it's good to know what that means. And it's not the end of the world. It's not bad by any means, but it's good to know what that means. There's another kind of type of reference, okay? Another type of label that points at commits, tags, okay? And they're kind of like branches, but they're not meant to move. Once you've created them, you're supposed to leave them where they were created. And a useful metaphor for tags are, if branches are, those sticky bookmarks that you can move around, tags are more like chapter headings, okay? They're like, this is a historical interest, historical point of interest in my project, and that's it. So typically you use them for releases, okay? This is version 0.3 of my project. This is version 0.4 of my project. And you wouldn't, once you've released your product, you wouldn't move the release tag after that. Reference, so it's just a generic term for branches and tags. And if you've got commits that are not reachable from any reference, okay, then they become invisible. If you try to run a command that's called git log, it won't show any of those commits that are not reachable from any reference, okay? They're still there. You haven't lost them. You can recover them, but they just won't show up. And if you wait for too long, the Git garbage collector is just going to remove them, definitely. Okay. Remote repository, that's another one that's slightly confusing, because it just means any other repo other than the one you're considering, okay? So let's say I'm working in, I've started, maybe I'm just writing a letter or something, and maybe that's a bad example. Anyway, so I've started a project, I've started a repository, and a remote repo can actually just be a repository that sits somewhere else on the same machine. So it doesn't have to be remote in the sense, it's on some distant server. It can be on the same machine. It just means some other repo that has a special relationship that the repo under consideration is aware of, okay? So typically you've got So let's say you want to contribute to a project that you found on GitHub. So you would get a copy of that repository, you would clone it, that's the term. And then that repository that sits on GitHub servers would be a remote of the one that you just got, that you just created on your own machine. Okay, that's what a remote repository is. And I'll just skip that. So these were a couple of terms that I found kind of misleading, or kind of, maybe not so intuitive when you start using Git. Now for pretty much complete beginners, I'd like to give a few tips for how to learn how to use Git and how to use Git effectively. Okay, so first of all, stay away from IDEs, okay? It's the surest way to make mistakes. It's a recipe for disaster. And it's also very hard to experiment, to reproduce stuff. If you want to experiment with Git, you want to figure out how a command works. Doing that in an IDE is kind of tricky. It's much easier to experiment, reproduce problems, and even talk about, go to Stack Overflow and explain the problem you're facing. If you say, oh, I've run that command, blah, 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 you'll get help much quicker, and for sure. So I would say, as you're learning Git, stick to the command line, at least at the beginning, and then when you're comfortable with it, you can always use Git in your favorite IDE. Most IDEs have some Git integration at this stage. Another tip would be commit often. Now that we've got a distributed version control system, there is no reason not to commit often. Okay, how often? It's really up to you. But as soon as you reach a stage in your project where, I'd like to save that. I'd like to save the state I'm in at the moment. Make a commit. Okay. That's what the distributed paradigm allows you to do. So every time you make a commit, you have to write a message describing, oh, this is what this commit is about. It's like, so if I go back to the snapshot or the camera metaphor, it would be annotating the picture saying, oh, that's me at the beach, on such and such a day. That's what the commit message is. And you shouldn't neglect them. They're really important because they explain to the future you and your collaborators what this commit was about, okay? So you should explain, motivate your changes, and if your company or the project has some guidelines or some style that the commit message should adhere to, you should stick to that as much as possible. So you should describe what the commit is about. And so if you don't have any policy about, this is what the commit message should look like, you can always use the conventional format that's prescribed by the Git project itself. So the Git project itself is under version control using Git. You can have a look at it on GitHub, and they prescribe using this format for the commit message. Okay. So you can have multiple branches, and you can give them names, whatever you want, but keep them short, okay, descriptive. Anything beyond, 20 characters is probably overkill, and don't use parentheses. Follow this link to see what happens if you use parentheses in your branch name, and if you use ZSH. Pretty interesting. So, of course, there may be files in your project that you may not be interested in keeping track of. Any file that's generated, you shouldn't be tracking it. You shouldn't be keeping a state of your generated files, okay? That's just bad practice, because you can always regenerate those files with your source files. So what you want to put in the version control is only your source files, nothing else. One exception is, so you've got one mechanism to tell Git, I'm actually not interested in that type of file, so anything that's let's say I'm writing something in, or let's say I'm compiling a C program. I wouldn't track the object files, for example. So I can tell Git, don't tell me anything about the .o files. They're in the folder, but I'm actually not interested in them. And the way you do that is using a gitignore file. Okay. So you can have multiple of those. You can say, oh, I'm on Mac. I'm not interested in DS store files. Okay, I'm not interested in that. So you can say, in any of my repositories, I don't care about those files. And then you can have repository-specific gitignore file where you say, oh, this is a project written mostly in C. I'm not interested in .o files. Okay, and if you have usually you would have a gitignore, a repository specific, so a gitignore file for your specific repository. This one shouldn't be ignored, because you want people who, let's say you push, so you make your projects available on GitHub. You want people who get a copy of that repository to also be able to ignore the files that should be ignored. Okay, so it's good practice to track the gitignore file as well.
Maybe just 3 more minutes.
Yep. Okay, I'll go quickly. So if you go to, if you're tempted to use those switches in Git commands, it should be like, take a step back and think of it. Okay, be sure you want to use them. Whenever you're starting to type force or hard, there should be alarm bells ringing in your brain. Should experience a slight quickening of the pulse. Sweat rolling down your back. Take a step back and think of it, because, for example, this command can wipe all uncommitted changes forever. So let's say you've been working on something really important and you're really, in the flow, and then all of a sudden you think you want to run that. All your work from the past hour is gone forever. Okay, so don't do it. Think back. Take a step back and don't do it. So I'm kind of running out of time. So there's this command called git pull. Don't use it. It's actually the combination of two, or roughly speaking, it's the combination of two git commands. It means whatever's on the remote repository, get the most recent stuff and integrate it automatically with my stuff. But in most cases, it leads to confusion, so it's better to decompose those two steps and do things more manually. This one is so if you're interacting with other people who are working on a different OS, you can run into trouble with line endings. So I'm not elaborating, but there is some, you can configure Git to not worry about line endings and to handle them automatically. And then before you share your work, so as I said, you're encouraged to commit as often as you can, but when you're doing work on your, on your own, you may not, write very good commit messages and stuff, or you may make more commits than needed. What you can do at the end is summarize and reformulate the history before you share it. Okay, so what happened there is, at this stage, so that's the project. At this stage, I got a copy maybe, and then I did work on my own. I made 2 commits, but in the meantime, somebody else made some work in that same project and pushed it to the remote. That reflects the remote. So what I can do, I could merge this branch with this and then send that to the remote. What I can do instead is pretend that I actually got this in time, okay? And I actually started my work after this. That's what I'm doing here, and that's what this rebase command does. Learn how to use it, but never use it on, so this has the potential to rewrite history, and you should never rewrite history that's public. Okay, if you've shared it or if it's already available, you shouldn't do anything that compromises history that's already public, that people have access to, because that means that in the future people won't be able to integrate. They won't be able to integrate their work with yours because repositories become incompatible pretty much. And that's very quickly for more advanced users. So of course you should agree on a branching workflow. You've got multiple existing branching workflows available. If you're not happy with any of them, you can devise your own, but once you've agreed with the team which one you're going to use, you should stick to it. If you've got a commit message policy, you can enforce it. Okay, you can force your users to actually stick to this policy by using what are called commit templates and Git hooks. I'm going to skip that. Don't forget about Git reflog. So Git reflog is a local mechanism that keeps track of where branches were pointing at the time. A branch itself doesn't remember where it pointed like 2 days ago, but this information is stored locally in the Git reflog. So if you moved a branch by accident, you can always, stick it back to the commit or it should point to using the Git reflog. If you use scripts, if you use Git commands in scripts, only use plumbing commands. So Git commands are divided between plumbing and porcelain. Those are more low level, and you should stick to those in scripts as much as possible, because those higher level commands can change. They can change. So you wouldn't write a script that parses the output of a porcelain command, because with the next release of Git, it might just break. This one is a good one. If you anticipate that, so let's say you're merging a branch and you're having loads of conflicts and you're resolving those conflicts, but it's taking you loads of time. If you anticipate that you're going to do that and you're going to rebase that branch later on, then this saves you the trouble of going through those conflicts all over again. Okay, it records. I can't remember I think it's recorded reuse resolution or something like that, and it's just a switch in Git, and it records how you resolve conflicts. It's great. It's very useful. If you've got a regression, you can locate it by using Git bisect. That's a good tool as well. And most of the time you'll be staging or resetting or checking out files, but you can also do that at a lower level. You can stage only lines of a file. You can check out only lines of a file. So you can do that using interactive staging. If you Google that, you'll find how to do that. A few learning resources. You can have a look at that in your own time. And for getting help, Stack Overflow would be my go-to place. Otherwise, you get the IRC channel or the Git mailing list, and that's pretty much it. If you get into trouble with your repository, if you can show people what your repository looks like, it's always a plus, and you're likely to get help more quickly. So that's my contact details, and I'm available for Git training. If you're interested, give me a shout. And that's it. Do you have any questions?
Maybe just one quick question.
Can you give two examples of porcelain or plumbing Git commands?
Sure. So git log, git status, git diff would be porcelain. And then you've got git for each ref, for example, which would be lower level. Git diff filter, if I remember correctly. But yeah, you would know porcelain commands. You wouldn't necessarily know the names of the lower level ones, the plumbing ones.
Thank you.
Okay.